I said the other day, nothing new to add to this, and this isn't going to be new. This is just going to be a different way of combining the last couple things we've done. Substitution and solving equations. So this is a way you can check your solutions. Sometimes they'll give you questions where it's asking you which value from a set of answer choices, and it'll give you 4 of them usually in brackets, and it's going to ask which one will make an equation true. You have 2 main options to do this. Option 1, if it's a fairly easy looking equation, you can just solve it. So we solve by doing the opposite. What's the opposite of minus 31? Plus 31. So if we add 31 to each side, cancels it out there, so all that's left is t. We add it up there, we get 158. That would be our correct answer. All right. So that's one way you can do problems like that. The other way is you can take each answer choice and substitute it for the variable. Sometimes you have to do it that way. So go ahead and give this one a try. This is one where you have to substitute. All right, who thinks I had the right answer? Noah? Nope. Aiden? So correct answer is 10. So for each of these, we did our substitution. We did each one in a different color. You do the math inside the parentheses first. That means inside the parentheses for the one in black, we got 6 minus 4. 6 minus 4 is 2. So then we got 2 cubed. That's 2 times 2 times 2. That's 8. 8 is not 216. So we go on to the red one. 10 minus 4 is 6. So we got 6 cubed. 6 times 6 is 36. 36 times 6 is 216. That means that one works. If we went to this one, we would have 64 cubed. And on the last one, we would have 72 cubed. 64 cubed would be 64 times 64 times 64. I'm not sure on that one off the top of my head. It's a big number though. Same idea with 72 cubed, 72 times 72 times 72. Remember when it's got that exponent, that's how many times you're multiplying the base by itself, okay? Any questions on that one? All right, try this one. This is one you could do either way. You can either solve the equation or you can do the substitution. Whichever way you do it, you can try to do it the other way always to check your answer. Who thinks I got it? Ben? Nope, not 3/8. Shane? 4/5. All right, so if we solve this, I have 3/4 times x equals 3/5. This is multiplication, so we would divide. So if I divide each side by 3/4, dividing by 3/4 over here will cancel it out. So I'm left with that. What do we do when we divide with fractions? Keep, change, flip. So we got 3/5 times 4/3. 3 times 4 is 12. 3 times 5 is 15. 3 goes into both of those, so when you simplify, you got 4/5. That'd be our answer. Other idea, you could always do your substitution and multiply on each of those. So if we put the 1/8 in, you would have 3/4 times 1/8. That would be 3/32, not 3/5. We got 3/4 times 3/8, 9/32. Doesn't work. 3/4 times 4/5 gives you 12/20, which does simplify to 3/5, so that one works. And just show we'd have 3/4 times 2/5. That'd be 6/20, which simplifies to 3/10. Okay, any questions on that one? All right, try one more with decimals. Odds are good you're going to see some equations with decimals. Who thinks I got it? Sophia? 47.60 is correct. Most of y'all were solving it, so you solve by doing opposite. Instead of minus 2.5, we add 2.5. Cancels there. We just line up our decimals. 1 and 5 is 6. Decimal comes down. 5 and 2 is 7. And then the 4. Adding zeros at the end doesn't make a difference. If we really wanted, we could add as many zeros as we want to the right of a decimal like that. So the 47.60 is our correct answer. Okay, any questions on that one?